So hello guys, it's me again, Mathew Javier, and for today's video I'm going to tell you more about chapter 9 tutorial about CCNA1 Introduction to Network. So chapter 9 is all about transport layer. Transport layer is data networks, and the internet support the human network by supplying reliable communication between people on a single device. People can use multiple applications and services such as email, the web, and instant messaging to send message and retrieve information. Data from each of these applications is packed, transported, and delivered to the appropriate application on the destination device. So the destination or the process described on the OSI transport layer access data from the application layer and prepare it for addressing at the network layer. A source of a computer communicates that with a receiving computer to decide how to break up data into segments and how to make sure that none of these segments are what you call for none of these segments get lost, how to verify all the segments arrive. And when thinking about the transport layer, thinking of a shipping department preparing a single order of multiple packages for delivery. So the next one is transport layer protocols. So transport layer protocol have transportation of data and TCP and UDP overview. What is the role of TCP and IP protocols? So the transport layer is responsible for establishing a temporary communication session between two applications and delivering data between them. An application generates data that is sent from an application on source host to an application on the destination host. This is with regard to the destination host type, the address of types of media over which the data must travel, the path taken by the data, the congestion on a link, or the size of a network. As shown in the figure, the transport layer is the link between the application layer and the lowest layer. They are responsible for network transmissions. So the transport layer responsibilities is tracking individual conversion, segmenting data, resembling segments, and identifying the applications. So the transport layer tracks each individual conversion following between a source application and destination applications separately. The transport layer divides the data into segments that are easier to manage and transport. So the transport layer ensures that even with multiple applications running on a device, all applications receive the correct data. So there are also converging multiplexing and multi-complexing. Multi-complexing is sending some types of data, for example, a streaming video across a network. As one complete communication stream can consume all of the available bandwidth. This will then prevent other communication from occurring at the same time. It would also make error recovery and retranslation of data damage difficult. The figure shows that segmenting the data into smaller chunks enables many different communication from many different users to be in travels multiplex on the same network. To identify each segment of data, the transport layer adds a header containing binary data organized into several fields. It is the values in these fields that enable various transport layer protocols to perform different functions in managing data communication. So segmentation allows the conversion of multiplexing. Multiple application can use the network at the same time. Segmentation facilitates data and transport the lower layers, network layers. So error checking can be performed on the data in the segment to check if the segment was changed during transmission. So that is transport reliability and TCP. What is a TCP? TCP transfers analogies to sending packages that are tracked from source to destination. If a shipping order is broken up into several packets, a customer can check the online to see the order of delivery. With TCP, there are three basic operations of reliability, which is the numbering and tracking data segments transmitted to the specific host from a specific application, acknowledging received data, retransmitting any acknowledged data from a certain period of time. Another one is a UDP. While the TCP reliability functions provide more robust communication between applications, they are also incur additional overhead and possible delays in transition. There is a trade-off between the value of reliability and the burden it places on the network resources. And adding overhead to ensure reliability for some application could reduce the useful of the application and can even be detrimental. In such cases, UDP is better transport protocol. So also it provides the basic function of delivering the data segments between the appropriate application with every little overhead and data checking. UDP is known as the best effort delivery protocol. In that context of networking, best effort delivery has reliable because of there is no acknowledgement that is received at the destination. With UDP, there are transport layer processes that inform the sender of a successfully delivery. It is a similar placing a regular non-registered letter in mail. The sender of the letter is not aware of the availability of receiver to receive the letter, nor the post office responsible for tracking the letter of informing the letter if does not arrive to the final destination. So next is TCP and UDP. TCP have a server process. TCP also have a connection establishment, and TCP also session termination. And there are always three. The TCP have the three-way handshake analysis. So the TCP three-way hardware analysis host track each data segment within a session and exchange info of what about data is receiving using an information in the TCP header. And TCP is a full duplex protocol where each connection have been two-way and streams or sessions. To establish the connection, the host will perform a three-way handshake. Control bits to TCP indicate the process of status of connection. So this is the three-way handshake. Establish that the destination device is present to the network. Second is verifies the destination device has an archive service and is accepting requests on the destination port number that initiating clients intends to use, and inform the destination device that the source clients to establish communication sessions on that port number. So that is the three-way handshake. So for reliability and flow control, there are TCP reliability order delivery, and TCP flow control size and acknowledgement. So TCP flow control while window size and acknowledgement is that also provides mechanism for flow control and amount of data that the destination can be received and process. Flow control helps maintain the TCP transmission, adjusting to the rate of flow control between source and destination for a given session. To complete this is a TCP header includes a 16-bit field called window size. So for TCP, that is all for TCP and UDP, or rather I do not click it on the next slide, but earlier I said that TCP and UDP. So again, I will add more to TCP UDP. There's UDP communication, UDP low overhead versus reliability, UDP diagram, UDP server and process and request, UDP client and processes, and the last one is the TCP or UDP. So there are applications that use TCP. So application that use TCP is that TCP is a great example of how different layers of TCP/IP protocols have been specific roles. TCP handles all associated with dividing the data streams into segments and providing reliability, controlling data flow, and reordering the segments of TCP frees the application from having to manage in this task. Application, like those shown in the figure, can simply send data stream to, transport, and use services of TCP. So the next one, thank you for watching this chapter 9 tutorial. I hope you learned something, and thank you for your time. And that is all, and thank you again.